For part A, we've got 16y to the 8, and that's all to the power of 3/4. Now this power of the 3/4, we can look at that in one of two ways. Either it's the 16y to the 8 all to the power of 3, and then all of that to the power of 1/4, or it's 16y to the 8 all to the power of 1/4, and then all of that to the power of 3. And we need to look at which one of those is going to be most straightforward for us to work with. I think it's clear to see that if you're going to cube everything first, that's going to make all of these pretty big. It will work, but I think it's going to get a bit, it's going to get too big. So let's try this one instead. So we've got 16 to the power of 1/4, and then y to the 8 to the power of 1/4, and all of that cubed. And working through that, 16 to the power of 1/4 is 2, y to the power of 8 all to the power of 1/4 is y squared, and we've got all of that cubed, which gives 2 cubed is 8, and y squared cubed is the y to the 2 times 3, which is y to the power of 6. So the answer is 8y to the power of 6. For part B, it's worth remembering this fact, that 8 is 2 to the power of 3. So in fact, when I've got 2 to the power of p times 8 to the power of q, the left-hand side there, I can write that as 2 to the power of p times by 2 cubed to the power of q. So let's simplify. 2 cubed to the power of q is 2 to the power of 3q, because it's 3 times q. So I've got 2 to the power of p multiplied by 2 to the power of 3q. So I've got the same base with different powers, and because I'm multiplying them, I add those powers. So that's 2 to the p plus 3q. Of course, all of that equals 2 to the power of n, because that's what we were given in the question. So you can quite clearly see 2 to the power of p plus 3q equals 2 to the power of n, so clearly n is p plus 3q, and that's your final answer.